What if I told you that something as basic as rain and sand poses a greater risk to wind turbine operation than lightning, severe storms, or even mechanical failures? Leading-edge erosion is this unseen foe that stealthily erodes turbine blades, decreasing efficiency and resulting in millions of dollars in wasted energy. This video will explain the true reasons for blade erosion, how it impacts turbine performance, and why blade protection is so important for the clean energy industry's future. 1. What is erosion at the leading edge? The cumulative deterioration that develops at a wind turbine blade's very front edge, the area that cuts straight through the air, is referred to as leading-edge erosion. Being the first surface to come into contact with wind, rain, sand, or dust, this part of the blade is subjected to the most severe circumstances. The smooth surface is gradually worn away by the frequent hits, leaving behind pits, fissures, and rough areas. The implications are dire, despite the seemingly sluggish process. A flawlessly smooth surface is essential to the blade's aerodynamic profile or its precisely crafted form. Efficiency starts to decrease, and the blade can no longer draw as much energy from the wind after erosion breaks its form. Visual signal: a blade's close-up graphic showing the location of the leading edge. 2. The science underpinning erosion. Let's examine the mechanics of blade action to have a thorough understanding of erosion. Blade tip velocity. From a distance, turbine blades seem to revolve slowly, but up close, their tips are moving at very fast speeds, often over 300 kilometers per hour or over 186 miles per hour. Even tiny particles hit the blade with amazing power at high speeds. Impacts of raindrops. It doesn't sound unsafe to have a single raindrop. At tip speeds, however, every drop strikes with the force of a small bullet. Millions of raindrops continually hit the same surface area during a storm. The surface covering eventually starts to erode. Hailstorms. Even more damaging are hailstones. They strike with significantly more energy because of their enormous size and greater bulk. The leading edge may develop craters, chips, and fractures as a result of frequent hail incidents. Salt, sand, and dust, airborne particles exacerbate the issue in desert and coastal areas. Sand particles erode protective layers, much like natural sandpaper. Surface fissures may deepen as a result of salt crystals in coastal air crystallizing and expanding. Weathering and UV exposure. In addition to mechanical impacts, blades are exposed to sunlight all the time. Protective coatings are progressively weakened by ultraviolet light, becoming brittle and more susceptible to erosion from sand or rain. Insect debris. Unexpectedly, insects are involved as well. The carcasses of insects that strike blades adhere to the surface, forming rough areas that obstruct airflow. Additionally, these areas retain more moisture and debris, which speeds up erosion. Visual signal: split screen displaying turbulent airflow over an eroded blade and smooth airflow over a clean blade. 3. The price of erosion, the impact on efficiency. Why is erosion so important? Aerodynamics holds the key to the solution. The goal of wind turbine design is to reduce drag and increase lift. Air moves neatly over the blade when the leading edge is smooth, enabling the blade to produce its greatest power. However, the rough surface creates turbulence once erosion takes hold. The wind creates eddies and swirls rather than a flat glide, which lowers lift and increases drag. Loss of energy. Erosion may reduce turbine efficiency by 3 to 5%, even in minor cases. Efficiency losses in extreme situations might amount to 20%. This might result in thousands of megawatt-hours of lost output annually for a single turbine. Impact on revenue. The financial losses are enormous on a wind farm scale. Over the course of a farm's existence, a 5% decrease in efficiency over dozens of turbines may result in millions of dollars in lost income. Costs of maintenance. In addition to energy loss, eroded blades need to be inspected, repaired, and sometimes replaced more often. This leads to increased downtime and higher operating expenses. Shorter blade lifespan. Blades are designed to endure at least 20 years. After only 7 to 10 years, serious erosion may require replacement or refurbishment if protection is not provided. Visual cue. A chart that contrasts the yearly energy production of an unprotected turbine with that of a protected turbine. 4. The significance of protection. Leading-edge erosion is an operational and economical issue rather than only a cosmetic one. Turbines that have their blades protected operate at their best and provide the highest returns on investment. Optimizing production, every efficiency percentage point counts. Turbines that have their blades protected will produce as much power as feasible during the course of their existence. Savings on expenses. Operators may minimize unscheduled downtime and costly repairs by minimizing erosion. Corrective measures are usually more expensive than preventive ones. Sustainability. Sustainability is the foundation of wind power. Protection helps produce cleaner energy by prolonging blade life and reducing waste. Minimization of risk. Blade integrity may be jeopardized by severe erosion. By lowering the chance of structural collapse, protective mechanisms guarantee safer operations. Visual cue. Animation demonstrating how turbine performance decreases in the absence of protection versus being constant when LEP is used. 5. Solutions. The protection of blades. Thankfully, leading-edge protection LEP options are now available thanks to technological advancements. These consist of coatings made of polyurethane. The leading edge of the blade is coated with flexible, long-lasting materials. These coatings provide durable protection, prevent cracking, and absorb impact energy. Films and tapes for protection. Special recordings serve as a layer of sacrifice. The wear is taken on by the tape rather than the blade. It is inexpensive and easy to repair when necessary. Composites and nanomaterials. In order to guarantee that blades withstand erosion for longer, certain producers are creating cutting-edge materials with improved durability. Frequent examinations. Early wear detection is made possible by combining protection with planned examinations. Early resolution of minor problems avoids later, expensive, extensive repairs. Visual signal. Blade cross sections with and without LEP tape placed side by side. 6. Implications of ignoring erosion in the real world. Ignoring erosion may have serious consequences. Let's think about actual repercussions. In only 5 years, a wind farm without LEP operating in a coastal area loses up to 8% of its efficiency, which translates into millions of dollars in lost income. The expense of emergency maintenance for operators is much higher than that of preventative care. Early blade replacement results in enormous waste and compromises wind power's environmentally friendly reputation. In the worst situation, unmanaged erosion may damage the integrity of the blade, increasing the chance of failure and posing safety problems. These results demonstrate the importance of never ignoring erosion. Conclusion. Although leading-edge erosion may seem to be a little surface problem, it is really one of the most urgent problems that contemporary wind turbines must deal with. The factors that produce erosion are persistent and inevitable, ranging from sand and UV exposure to rain and hail. They shorten blade lifespans, decrease efficiency, and cost millions in wasted energy and maintenance if left unchecked. Fortunately, protection is effective. Operators may increase energy production, prolong blade lives, and preserve investments with the proper cutting-edge protection, whether it be coatings, tapes, or sophisticated materials. This is where WindLab is useful. At WindLab, we provide immediate advice on the best LEP solutions based on the specifics of your location. Our professionals can assist you in selecting the best protection plan to maintain your turbine's optimal performance, regardless of whether you operate in a desert, coastal, or storm-prone area. Allow WindLab to direct you toward the cutting-edge protection your turbines need if you want your wind farm to continue being effective, lucrative, and sustainable. Thanks for watching. Don't forget to hit like, share, and subscribe.